This is a production of Cornell University.
So I'm Ben Gutierrez. I am the geneticist and curator of the apple and tart cherry collection with the Plant Genetics Resources Unit. And so we are part of the United States Department of Agriculture program of the National Plant Germplasm System. And that's a mouthful, but we are a site dedicated to crop conservation. And so we are one of 20 sites. I tend to think we have the more glamorous crops. So we have, you might have seen some of the seed crops from our other curators on site, but so we have the clonal crops here. All right, so we're here standing in the tart cherry collection, which is more of a minor crop in terms of the size of our collection. So we have about 142 active tart cherry accessions. And so tart cherry is interesting because it's not, it's not a sweet cherry, right? It's its own unique thing. It's actually a tetraploid hybrid of a sweet cherry with a wild European dwarf cherry. And there are some interesting properties that come out. So a lot of nutritional value and definitely a unique eating experience. But we're standing in front of one of Cornell's varieties called Surefire. And I think by the fruit load that you can see, it's aptly named. So if we were to contrast the tree right next to me, you can see definitely a different crop load. And so this one tends to bloom much later than some of the other cherries in the collection, which again, it's going to avoid a lot of the frost damage or potential damage due to the kind of volatile New York springs. And so highlighting this tree again, this is Montmorency, one of the really dominant cultivars grown in the United States. And so this does tend to take a lot of damage in our collection every year just due to frost and that early spring warm and then quickly freeze. And so I always highlight this particular accession when we start talking about diversity and its value, because imagine a whole crop production based on this accession or this particular cultivar. You can see how quickly you could lose an entire crop just due to climate conditions or other conditions that we can't control. So really genetic diversity is really lacking in the US tart cherry industry, and that's not for lack of access to material. So our tart cherry collection comes primarily from Michigan State, from Dr. Amy Iazzoni, who was the tart cherry and rootstock breeder there. So she did a lot of explorations throughout Europe to bring back a lot of this material, which is the majority of our collection. So I've got some show and tell here. So this is a Hungarian variety which ripens several weeks earlier than even Montmorency in the United States. But I mean, you can see super just beautiful large fruit and a delicious flavor as well. And then we still have some of the accessions are weeks behind. So these still have a ways to go in terms of fruit expansion and ripening. So each two trees is unique in our collection. Again, contrasted with an orchard system where every cultivar might be the same, kind of a monocrop there. But you can see just the beautiful crop load on this particular accession that's really weighing down the branches. Again, it looks ideal, and maybe we get a lot of criticism. Well, why aren't growers growing this? Well, it might not match up to what the industry is looking for. So mechanical harvesting, uniformity, and just whatever the market really demands. So most of the tart cherry industry in the US is dedicated towards processing or some other application, not necessarily fresh eating, which I hope will change, because there are some delicious tart cherries here that I think would do well in a fresh market. So one of the challenges of maintaining a clonal diversity collection is most of our collections are maintained in the field, which means they are susceptible to disease, to the elements. We lose lots of branches just due to heavy winds that hit the collection. These two particular trees are really struggling with a disease that makes them already weak and vulnerable. And the challenge is, again, like the only way really to maintain the diversity is to clonally propagate it. And so tart cherries don't do very well in cryopreservation, where we can store bud material in liquid nitrogen, kind of in a safe, out of the environmental conditions. And so that really does make us rely more heavily on these field, collections. Which again, there's really no easy way to replace some of these cultivars if they're lost or to disease or to the environment. So we mentioned that tart cherry is a tetraploid hybrid. So this is the European dwarf cherry, Prunus fruticosa. So you can see a very distinctive dwarf habit, small fruit, and again, not all that desirable fruit quality. You can actually go back to the sweet cherry and do a tart cherry sweet cherry hybrid, and that becomes a Duke cherry. So this is a Hungarian landrace that Dr. Iazoni brought back, and just amazing fruit. Tart cherry has a really distinctive soft fruit texture in contrast to the sweet cherry. I prefer it. A lot of my colleagues just don't, and so the taste preference for tart cherry, or for cherries in general, tends to be on the more crunchy side in North America. Certainly with the growing and the kind of worldview and all the palates that we're exposed to in the US market, certainly I think there's a place for more diversity in crop and flavors and textures, and hopefully in the future. So really, you need to be in here. You need to come visit the collection, because it's really difficult to talk about, easier for you to just walk through and see. And this really is kind of mind-boggling when we're used to, horticultural or orchard systems where uniformity is paramount, right? We want precision in agriculture. We're kind of dealing with all of the genetics. Sometimes it's kind of messy. So in terms of things bloom at different time, the spray application, disease resistance, it's a challenge for us. All right, so we are standing in the United States Department of Agriculture Apple Diversity Collection, and it is really a world premiere collection, one of the largest and most genetically diverse of its kind. So we typically have about 5,000 to 6,000 seedlings or trees on site, and we also have a large seed storage of Malus wild species in a seed vault preserved at -20 Celsius. But again, the challenge with clonal conservation is that we do need to keep trees in the field for evaluation, for access to the germplasm. So really, as a curator, we really do need to balance accessibility and vulnerability of the genetic resources. So we are standing here in what we call the core diversity collection of the apple, which is 250 distinct accessions that represent the diversity of the entire apple collection. So here we have lots of common or popular cultivars, some developed here at Cornell, including Empire and Jonagold. And then we have a lot of wild material. And so one of the big things that when students or visitors come to see us, they look at some of these small fruited trees and they say, what's the value? Well, apple is unique in that all species are you can do intercrossing or interhybridization to bring in some of the interesting or novel traits of the wild relatives into a domesticated background. And that is really important when you start thinking about disease resistance or climate adaptations. And the overall goal, right, is to increase sustainability of our crop production. And genetics plays a really large role in that effort to promote sustainability. So we're thinking fewer pesticides, easier maintenance, easier harvesting, and those traits can be mined from diversity collection like ours. And so typically this is our largest and most popular collection, and we do receive a lot of requests for material. So it's a free service that we offer to researchers and our commercial partners. And they typically request scion material so that they can propagate the material for their own. But we also do fruit requests, and people characterize or they request pollen for their own breeding purposes. But we are a collection that's not only here and maintained, but utilized. And that's the most important aspect, I think, of our effort. I mean, what's the point of keeping things if breeders or researchers aren't going to use them? And so we typically fulfill about 500 requests and send out about 5,000 units from our collection annually. And that number just seems to be going higher and higher. And that's an excellent indication of our value to our stakeholders. So the apple collection is unique in that we have one of the best backup systems in using cryopreservation. And so we do lose a lot of our trees just primarily due to fire blight. And so having that backup, and I know typically one of the points I always try to make is that cryopreservation isn't just end of the world scenarios. We heavily rely annually on receiving that material from backup. I mean, part of the challenge of maintaining diversity collection is dealing with diversity of susceptibility and vulnerability to these diseases or environmental conditions. And so it's about 60 to 70% backed up in cryopreservation. So it is a little bit early in the season, so it is, you know, there is tremendous diversity in just the way that the trees look and their shapes, and you can see some of the indications of fruit. But here is one that's particularly interesting. This is called Robert's crab, and this has a novel red flesh to it. I mean, this, you can't even see any white by the end of the season. It's just pure red. Which again, I think novelty in horticultural breeding is the future. And so these new varieties that come out have to compete with, you know, not just other apples, but, you know, all fruits from all over the world, as we, you know, the markets are kind of flooded with more exotic fruits. And so here's an apple that has, you know, not only a beautiful red, deep red on the outside, but it accumulates anthocyanin on the inside. So kind of a novel eating experience. This is Robert's crab, really starchy, kind of a terrible flavor, but I think within a few generations of breeding, and certain cultivars have come out red flesh that are, you know, much better in terms of dessert or eating quality. Yep. So during the initial founding of the collection in 1983, the collection really was heavily focused on acquiring cultivars and pre-breeding material. And then we saw this transition over to collecting crop wild relatives. And so one of the most, you know, important crop wild relatives is the progenitor species Malus seversii. And so Phil Forsland, the first apple curator, organized an exploration with Herb Aldwinkle from Cornell University to go to Kazakhstan to collect apples from the origin. And so apple really is a unique crop in the US, because we claim it as our own, but really it's quite an exotic fruit. So its origin was from Kazakhstan, and it was traded through the Silk Route into Europe, where it hybridized with another species, Malus sylvestris, a European crab apple. So with Malus seversii, typically you'll see a little bit larger fruit similar to the cultivated apple, but it's lacking that acidic punch that consumers really want. So so it's got sweetness and size, and then the European Malus seversii has that high acidity. And so you combine the two and you get this beautiful, you know, contrasting flavors. And so from there we get this hybridization effect that led to what we know as the modern domesticated apple. And certainly there has been some selection for fruit size and sweetness and acidity, but really apple in its roots and its genetic diversity is still quite untamed. And so there's a lot of potential that we still find, and a lot of allelic and genetic diversity that's still really untapped, looking at the pool of domesticated cultivars as well as the crop wild relatives. So we've learned a lot about apple domestication and its evolution by looking at its progenitor Malus seversii. And so we have one of the elite collections, premier collections of Malus seversii in the world. And kind of coming full circle was just over the recent years, collaborators from Kazakhstan have been requesting the material to come back to their country. So we have a repatriation act, or activities that we're trying to do to help them reintroduce their heritage apple there. So some of it is, you know, so some of the diversity of Malus seversii is endangered in its origin. So a lot of deforestation or other activities causes loss of that genetic diversity. Another challenge for wild apple is admixture, is that hybridization or cross-pollination with cultivated apple. So a lot of the times we go out and explore for wild apples only to find that they've already been hybridized by commercial or cultivated blocks, which is a challenge. We want as pure wild as we can, so we can understand the unique attributes of a particular species. So our effort, largely to support our Kazakh colleagues, is to help them reclaim the material and reintroduce, kind of prevent any future loss of Malus seversii. We're standing at Golden Delicious, which maybe, again, at this early stage isn't as recognizable, but this is one of the most important cultivars in modern breeding programs. So pedigrees and genetic studies really show us that modern programs really have relied heavily on about 15 accessions or 15 cultivars in apple improvement, which is kind of scary, right? Like we look at the full diversity of apple, and here we've been using a really, narrow genetic base for improvement. And we do see that changing a lot with introgression of wild species. And again, genomic selection and genomic resources really do help us better leverage wild and more diverse apple genetic resources. This one, again, does have a unique story. When it was first developed by Stark's brothers, they put it in a cage. They found this novel tree that they saw potential in, and they didn't want anyone else stealing it. So they erected a steel cage around it so people couldn't steal the germplasm. And that really, as breeders and as this group, right, we really do, want to safeguard what we have, right? But we have a kind of an opposite mission to really share this material with the world. We want more people to have access to our genetic diversity so that breeders can make their advanced, selections.
This has been a production of Cornell University, on the web at cornell.edu.